So following a keynote like this is never fun. So thanks, Regis. So I'm going to be basically just talking about something that I think is generally overblown a lot in the Python world. People talk a lot about how Python's people talk about this global interpreter lock, and they always blow it out of proportion, and they always talk about how things are slow because of it, and this and that, and that's just generally not true. I'm also gonna focus on some changes that are coming up that will sort of make it optional, and just a rollout of that. It's going to be fairly high level. I'm not intending to sort of read out the PEP to you here. That was very dull. So, but I highly encourage you to read PEP 703. It's included in the references, and it's fairly easy to follow. So, what's a process? It's an instance of programming in execution. That's all that happens as far as an operating system is concerned. There's that's how memory is set up. And there's a stack, there's heap, there's the register counter, that's all fine, and then your code is executing below. What's a thread? That's the unit of execution within a process. So things that are happening within your system or within your program. Actually, what's happening, what's executing within it is a singular thread. So within each process, there's multiple threads, and any one or more of these can be running at a particular time. So we've got sort of a demonstration of that. In Python, the challenge that we have is that at any one time, only one of these threads can actually be executing Python code. I'm sort of giving you a caveat, and I'm being a bit vague about this because it's Python code in particular. Libraries like NumPy, there's PyTorch, etc. Actually, sort of surrender the global interpreter lock, such that they can do multiple things at the same time. And when you're dealing with I/O, even in sort of standard Python, the GIL is released because there's not a lot that you need to sort of freeze access to types and objects for. So how does this impact people? People frequently talk about how Python's not very good at doing concurrent things. That's patently untrue. So the fact that you've got async I/O now, it's been around for a while, you can definitely do multiple things concurrently. What you cannot do is multiple things in parallel. So what's going on here, and it's a small distinction. Concurrency and parallel are not the same thing. I've stolen from the best. You're gonna steal from Rob Pike, and again, this blog post and there's a talk associated with it. It's excellent. Really, really helps you understand the distinction between concurrency and parallelism. Again, I've straight listed from those slides. I have quoted the sources. So this is effectively a singular process that's going on, and this is actually a Gopher burning manuals. I like to think of it as references to languages I don't like. Insert your language here. And when you're talking about parallel processes that are going on, you can have effectively two piles of these that are being processed at the same time. In Python's case, unless you're making an external request and you're doing asynchronously, you cannot have the second Gopher going at the same time as the first one. So there's a short summarization of this. It's about you can basically coordinate multiple things at once very easily in Python. So say you make an HTTP request and you're waiting for the response. You make multiple HTTP requests, waiting for multiple responses. That's absolutely fine. However, if you need to compute multiple things at the same time where you're not waiting on an external resource, Python is not so hot at that at present. So why does this matter? I mean, most times web programming, you can run multiple processes, you can use async IO, et cetera, et cetera. Well, there's perhaps a somewhat niche application these days, in machine learning and artificial intelligence. And people are starting to use it a little bit in Python now. Starting to use Python a little bit for those disciplines now. And one of the things that's happening is Facebook sort of released PyTorch, and there's a ton of organizations that have adopted it. Seems to sort of be running ahead of TensorFlow. And the challenge that they're having right now is they actually need to coordinate, thousands of processes, and trying to do it with a single thread isn't working so well. So there's sort of been a long-running goal to try and be able to compute multiple things in parallel within Python code, as opposed to having to defer to other libraries. There's challenges with that, right? So you get some speed ups, but you have to deal with the same stuff. There's race conditions, there's and the challenges that you have are, it's not going to magically give you the ability to do more IO at the same, spontaneously. Just because you can compute more things at once does not mean that you can read in more data or output more data if you run more than one thread. So Python basically has, there's the abstract summarizes it beautifully, right? It says you cannot execute multiple threads at the same time in Python at present. This is, again, only for Python code. So people building packages have the unenviable task of having to manage a lot of simultaneous execution, lock memory and all of that within their modules, because Python doesn't provide facilities for that at present. And how do they get around that? So the way they get around that right now is the global interpreter block. So right now, if you need to say write to a list, the way Python's managing it is it's effectively giving exclusive access to a thread, and it's preventing any other thread from writing to it. You insert a value, the global interpreter block is released, and then the next thread is given access. And in this case, exclusive access, because the global interpreter block. The advantages of this are also that unless you want to go through the rigor or the challenge of having to manage thread safety and access yourself, C extension authors can just defer to the guild. Generally speaking, smarter people than most of us have worked on this, and so they don't have to, and because the design of the language is such that they're providing guarantees that multiple threads are not going to be writing to objects at the same time or manipulating objects at the same time. You can basically, when writing your extension, you don't have to worry about having to deal with concurrent access issues and locking, etc., because the guild is doing it for you. And when you're running, this strategy works really well when you're only running a single thread at a time. You don't have to worry about having to, do fine-grained locking of objects. So what have people done so far as dealing with the single execution of a thread at a time in Python? Well, there's been other approaches. So Python has the multiprocessing module. Who's used the multiprocessing module here? Who's tried to kill the task that gets spawned from multiprocessing successfully? Has it been fun? So generally, and I think the other challenge multiprocessing presents is, again, data sharing, right? It's inefficient. You have to, it's not quite as straightforward. Again, there are opportunities to release the GIL. So even in the standard library, IO releases the GIL. There's the Python standard library image processing modules that are in C manage to release the GIL, and some of the compression modules release the GIL already. So it's not like it's not been done. And again, the sort of most commonly used external modules from PyPy, NumPy does. NumPy does not sort of do it all over the place. Only within inner loops is the GIL released. Scikit-learn does that. There's been another approach as well. So there's been another recommendation, which is doing multiple interpreters. So Python has, you can, within the CPython API, you can create sub-interpreters. And that allows you to basically, get around the GIL by having n interpreters. But again, it's a much more convoluted approach than you'd have for many other languages. Threads, unfortunately, are not yet a workaround. So why hasn't this happened yet? It hasn't happened yet because the PSF had established certain contracts. The idea was, when you wanted to deal with fine-grained locking and all of that to allow multi-threaded, simultaneous multi-threaded execution, you couldn't do it at the expense of significant performance hits to single-threaded code. That's because there's been huge adoption. There's been a ton of people who've been dealing with very large projects with the GIL in place, and they didn't want to just take a hit so that multi-thread could execute. Existing C extensions, they assume the presence of the GIL, as I suggested earlier, and you can't necessarily break those just by sort of changing the way you manage locks in Python. And sort of the third thing that did come up is the implementation shouldn't be so complicated that people working on CPython just find it impossible to work with after the GIL removal happens. So there were prior attempts. The earliest one that I came across was this patch that you could apply to Python 1.4. And it did get rid of the GIL. However, it violated sort of the first requirement. It was multiple times slower for single-thread performance compared to the unpatched version. So it wasn't adopted. Then similarly, Adam Olsen, for when Python 3.0 was happening, which was probably a contentious enough time given the 2 to 3 transition, he did safe threading work, and this code's also still available. But again, the performance hit was about 35 to 40%, and it didn't take. 2016, they did something that Larry Hastings, who's one of the core committers, did something that's wonderfully called the Galectomy. He did a great talk at PyCon. I'd really recommend that you take a look at it. And the challenge there was that things like weak refs in the CPython API just broke. And so that wasn't going to go very far. And the implementation required somebody as smart as Larry Hastings to do it. And not everybody was as smart as Larry Hastings. So they decided this wasn't necessarily a viable way to deal with the GIL in Python. So more recently, since the rise of PyTorch, again, as I suggested earlier, they discovered that when they were training huge models, and they were just a coordination of processes and keeping multiple GPUs fed was beyond the capacity of a single thread. And as we know, when Python initially started out, most machines were, you had a single core, multi-core machines, or multi-CPU machines weren't that common. Now, it's quite common to have 3264 cores running on a server. And even if you effectively associate one thread per core, it's quite useful to be able to execute all of them at once without having to resort to things like multiprocessing or running multiple processes and having to coordinate between them. So a guy called Sam Gross, who is currently at Meta, he has proposed, he wrote a PEP, which is PEP 703, and it has been accepted. However, there's a caveat to this PEP, which is if they don't like it, it will all be rolled back. So please do not build production code at present. And even after 3.13, it could still be rolled back. So, here we dragons, please follow very carefully. Supposed to be released later at the end of this year, on October 2024. And what's going to happen is the C extensions will need rebuilding. There will be some small modifications, but it's not like the C API is extensively broken. However, the most useful thing they managed to achieve is it's less than 10% slowdown for single-thread processes with CPython. So how did they do this? So Python previously had memory allocation in Python was done by an internal library that was used to manage memory. Microsoft had a project called memalloc. So they adopted memalloc, which allowed them to sort of allocate memory in a manner that was more compatible with multiple concurrent or multiple simultaneously executing threads. They also had to change the garbage collector. Previously, with the GIL, what would happen is you'd basically, when garbage collection was happening in Python, or you'd basically the GIL would just be executing the garbage collection loop, and you're golden. The change has been that now you're simultaneously executing threads are all stopped during garbage collection. So they had to make a change to the garbage collection system that's in place. So Python 3.13 onwards will have 2 parallel garbage collectors depending on how you're running. And object locking change. So that slowdown that I mentioned, the 10% slowdown, now locks were much more had to be fine-grained on a per object level, as opposed to being done, being managed just by a single global lock. And so there was more complexity and more coordination, which led to a decrease in performance. So I'm going to demo. What does this mean? Okay, this is all very nice, and this is all great. What does any of this mean? So there's a fairly straightforward program here. Is this readable? Okay, right. So this is useful just to show off that it's a no-GIL build. I tried to build without the GIL my own version of Python, and I failed miserably. So if anybody else has done it successfully, please come chat to me and tell me what I've done wrong. I ended up having to use the pre-built no-GIL variant. This is just using the standard Python threading library. And we've just built a thread pool executor. We've just imported the thread pool executor. This line 5, is basically just when you have a sort of an optional guild build of Python, there's another sysflag available, which is the no-guild flag, and if it's available, then you know you've successfully built it. I never successfully managed to get this in my sort of intermediate builds of Python. So, and in order to sort of demonstrate the fact that we're simultaneously executing multiple threads, I wanted to build I used an example in that was already provided, and this example is a good one because it's CPU bound. Clearly, it's going to be something that's going to require, if multiple threads are executing at once, they should run faster, right? So we have, and over here we're sort of defaulting running 8 threads at once unless you provide an argument, and this is going to print a thread ID, which is going to be an arbitrary system thread number, but it'll just demonstrate that it's going to be running multiple things at once. So here we go, right? So this is running in a standard build, Python 3.12, calculating Fibonacci in 8 threads. So here we go, and we wait, and we wait, and we wait. Why is it happening? We're trying to do this with 8 threads at the same time. Guess what? 8 threads cannot run at the same time. So things don't go so well. And our overall execution time is 16 seconds, right? 8 threads happen, roughly 2 seconds. Now, trying to do the same thing in the build, in the no-guild build. Now, this is getting slightly cut off, so I'm going to move this to the right a little bit. It should say no guild true, not guild true. And if you look, we're done. It's 1.25 seconds. So we had 8 threads executing. They all executed once, and we got the Fibonacci number calculation going on. So there are significant speed ups for simultaneous threads. So this is sort of a big deal for people who really, really need to utilize all the cores in their machine, who are using CPU-heavy workloads, and who are working in situations where they're not dependent on external resources and can't do things, can't just use async IO. So, if you have a big server, you don't need to do things like spawn up multiple processes or use multi-processing or deal with the complexity of having to coordinate data sharing between them. The threading library will just give you most of this now. Granted, you're going to have to still deal with multi-thread programming, but you have to anyway. The challenge here will be that it's going to be dealing with multiple threads executing at once, so you will have to deal with some issues as far as race conditions and deadlocks are concerned. Okay, so back to okay. So when is it happening? There's a prep schedule for it, and it's going to start out in October 2024. You will have to either build Python yourself, or what they are doing is they're going to be distributing a no-guild build, as well as distributing a bunch of modules that are built to work with the no-guild build, but it's going to sort of slowly ramp up. You're not going to necessarily be able to download any module and have it work perfectly. Should a module need the guild, it will automatically stop. It'll automatically sort of bring the guild back. So what's the outstanding work in this space? The outstanding work in this space is that at less than 10% single thread performance, the exact numbers are actually available in a very nice table in the PEP. They do need to work to reduce the slowdowns. Even that 5 to 8% performance hit is something that they don't want to have to pay anymore, because performance is, there's a lot of work going on in Python performance that Guido's working on and other people in the Python core team are working on, and getting rid of the GIL shouldn't necessarily defeat their efforts. So the rollout's going to be kind of gradual. So initially, as I said, the disabled GIL flag is going to be off. In about, I think, another 2 to 3 years, they're going to sort of set the disabled GIL flag to on, but the GIL will remain on. And so the idea there, again, is it's a transitionary period. You'll be able to sort of shut the GIL off if you want, but you're not gonna basically be running with the GIL off at the same time. And finally, 2027 to 2030 is when they're talking about the GIL being off by default. It'll still be available, so it's not going to break old libraries, but it's going to be off by default. So what does this sort of really mean? Again, just to recap, this is only useful if you want to utilize multiple cores within the same program, and you don't want to use things like multiprocessing. If your process is CPU bound, if you can parallelize it, this is going to be a win for you. However, it's not going to somehow magically allow you to do things like speed up database calls. It's going to be able to do more of them, and you'll possibly risk overloading your database. You're not, again, multiple client requests. Most times you're waiting on the response as opposed to kicking off multiple requests at the same time in multiple threads. So it's not going to allow you to do that magically. Going back to the shell, so there's going to be a flag available, and so this is the experimental no GIL build. So what really matters is this last one. Over here, no GIL is set to true. This is a standard build of Python. And over here, actually, there is no option to, there is going to be nothing as far as no GIL is concerned. It's just not aware of that being available for it. So should you want to defeat it, the mechanism for this is going to be, so we did this demo previously. There's a nvar available, where the GIL is back, right? So now we're running sort of old school slow Fibonacci calculation again, and it took 8 seconds this time. So this is going to be toggleable. They're doing it in a highly backward compatible manner, but good things are coming. Let's hope they don't roll it back, and the hit that you have is not that significant, or not sufficiently significant that you're able to use it. But I'm pretty excited about this happening, and I really hope that it lands. So, any questions? Yep. Good.
Thank you so much.
Yeah.
I was curious specifically
Yeah. I think the glib answer to your question is yes. However, what the PEP describes a much more, in more detail, the garbage collection approach they've taken. They haven't settled on one. For some reason, currently they're down on JVM style concurrent garbage collection. My knowledge of garbage collection approaches is not sufficiently nuanced to be able to sort of give you a particularly intelligent response on why.
Do you think the 10% overhead is comparable to other languages that support multi-threading? Like, I don't know, Java perhaps?
I haven't actually looked at sort of comparisons of multi-threaded Java code versus single-thread Java code. I'd venture a guess saying that they've spent so long tweaking the performance of the JVM that I'm guessing the multiple thread overhead on the JVM is lower. And now with Java 24 or something, with Project Loom, with all of the virtual multi-threading stuff and all that, I suspect they have even bigger improvements.
So it seems contrary to that, it is 50,000 on the store now. It's like, become more error prone, but why would it slow down?
Because you need to manage loss. Yeah. So the gentleman said with the first attempt at GIL removal with Python, let's see, there was a significant slowdown, 35 to 40% slowdown. So why that? And so if you look at what they patched, the idea was that they now had to manage the locks at the per object level as multiple threads were managing them, and the implementation wasn't particularly efficient at that point. So they had a massive slowdown in order to make sure that you didn't have race conditions when you were doing things like modifying lists or objects.
It was due to like not being heavy.
Correct.
Right. Are there any web servers or experimental web servers that
well, I'm guessing that if you talk to people at Meta, I'm sure they're playing around with it, but they aren't sort of available mainstream. So it's not quite like the ASGI, WSGI transition where you could sort of use async web servers. They're not quite there yet, particularly since they're 10 years from now, whether they're going to keep it.
We talked about 7.2 and 554, which is about multiple integrated using multiple languages. Then this other proposal, which was created in 1 March, and it is 654. And it says that in a single process we use multiple integrators, and that shares significant amount of state, and that is the source of work and so on and so on. So they suggested that you can use per integrator law, and then what it does is basically it doesn't share field between integrators, and that can improve a lot of multi-core features. So why do you think that doesn't have a potential and 7.2 has?
So I mentioned that in on this slide. So it's just because the model is different. So most people expect multiple threads to be executing at once in most languages, and they want to be able to coordination there, as opposed to first of all, that 684 stuff, 684 stuff that I read about at least was initially only going to be available on the C API. It was not going to be available from Python code directly. And so you'd basically have to, build a little wrapper around your code. The other thing is that even with sub-interpreters, sharing state is not going to be quite as straightforward as doing it with threads.
So do you have stats on that? Like, what kind of whether it be faster or
I haven't looked into that, to be perfectly honest, so I would be lying if I gave you any answer.
Other languages like Python ideal, and if they don't, if they sort of have Python implementation, that's maybe go harder.
So I believe Ruby does. I'm not sure about Lua. I don't know if you're aware, Peaches. And again, there are other implementations of Python that claim not to have it. So Jython doesn't have the same limitations, but you have, most of the CAPI extensions are available. PyPy has the GIL. And again, JRuby doesn't. And I've done some Ruby, but I haven't done it long enough to really know whether they're on par with the sort of MRI main Ruby distribution performance and with JRuby.
Thank you, Adi.